Okay, so a lot of things in there we've heard before. A lot of things that most of it's just kind of review. Like you guys, nothing in there that you guys haven't heard before. A lot of buzzwords, a lot of keywords. But what we have to do now is we're going to do the exact same thing. We're going to do the exact same thing we've been doing, just without. They're not going to give you f of x. On last week and the week before, they said here is f of x. Find these things. Find these things. What else? Right? Find all of those things. That's what you guys did on the quiz, right? Today we're going to do the exact same question. It's going to say find those things I highlighted, except they're not going to give you f of x. They're not even going to give you a picture of f of x. They're going to give you f prime. And you have to determine all of those things from a picture. Okay? So first thing we have to do is kind of get our mind around those things. So first, let's start with the yellow, increasing, decreasing. What do we need to find intervals of increasing, decreasing? What do we need? If I said, I need you to find intervals of increasing, decreasing, I did on the quiz. What did you need? What was it that you needed? Hmm? I needed f prime, right? That's what I needed to do the first derivative test. Okay, so let's put that over here. Intervals, let's see, increasing, decreasing. Okay, increasing, decreasing. Increasing, decreasing, I need f prime. Okay, let's go to the next one, relative extrema. Relative extrema, what did I need for relative extrema? Relative maximum, relative minimum. What did I need? F prime as well, right? So let's make a list. It goes in our F prime list. Relative extrema. This one wasn't on that paragraph, but it was on your quiz, right? Absolute extrema, too. We used F prime, right? Okay. So let's move down our list now. Green, concave up, concave down. What do I need for concave up, concave down? Second derivative. Now double prime, right? Concave up, concave down, right? That's what we need. You did that on your quiz. Okay. Points of inflection, the last one, points of inflection. What did I need for points of inflection? The points of inflection, double prime, right? Good. This is not new, but today it's going to be important because if they ask you where is it increasing, where is the function increasing, where is the function decreasing, you're going to need to know, what do I need? What do I need? You need f prime, right? If it says what's the points of inflection, what do I need? I need f double prime, right? So that's important to keep straight. These are things that we've done already, okay? So here's the first picture. Not even concerned about the question. I'm not even concerned about the question A, B, C, D. We'll get to that. But I just want to read the context. The function f is defined and differentiable on the closed definition or the closed interval from -6 to +6. That means everywhere for f, everywhere from -6 to +6, f had a derivative and it was continuous. Okay. The graph of y equals f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure below. So what does this picture represent? What is this picture of? This graph here. What is that of? F prime, yeah. It's the derivative graph. So that's important. It's not f. It's the derivative graph. Let me put that better. Graph of the, let me just make it simple, f prime. This is a graph of f prime. This is not the original graph. This is not the original graph. This is the graph of f prime. Well, what does f prime represent? What does f prime represent? F prime represents what? The first derivative. But more specifically, yeah, you're right. But more specifically, what does f prime always represent? The derivative of the first, okay? So use, instead of derivative, use a different word. What does f prime always represent? Of the original, right? It represents slopes. All of these, this is a slope graph. This is a slope graph. I'll give you an example. Let's start with -6, right here. That red dot there. When x is -6, what is y? 4. So what does 4 represent? Right? Because it says f, we got this, right? 6 represents x, right? What does 4 represent? So, sorry, -6 right here. So you're close. 4 represents the slope of the tangent line of what? The original graph. The slope. 4 was the slope of the tangent line, right? 4 is a slope, right? Let's go to the next one. This guy right here. Let's just use their dots. At -4. -4, 0. So f prime -4 equals 0. What does 0 represent? Slope of? Here you go. So the slope of the tangent line at -4 of the original was 0. So what does that mean? If I had a slope of a tangent line of 0, what does that mean? What does that mean if I have a slope of the tangent line of 0? Okay, keep going. It's not increasing or decreasing. Keep going. What else does it tell me? It's going to have not a horizontal asymptote. It's going to be a horizontal tangent line. Right here, this dot right here was a horizontal tangent line, right? At a horizontal tangent line. Well, what do we know about things that have horizontal tangent lines? What happens there? Well, it's not going to be either. It's going to be 0, right? So what do we know about things that have tangent lines of 0? Horizontal tangent lines. What do we know about things that have horizontal tangent lines? See, this is why this is tough, because you got to use your brain. You got to think about it. We've used this before. Things that have horizontal tangent lines of 0. What is true about them? What is true about them? No. What is true about things? Because they're critical points. That's one of them. They're critical values. So we know -4 is a critical value. Keep going. If they're critical values, what are they? They're either a relative maximum or a relative minimum, right? So this guy right here is hugely important, because that guy right there is either a relative maximum or a relative minimum, and it's a critical value. Okay? Hugely important. That's the kind of investigation, that's the kind of work we're going to do today. Okay? That's the kind of work. So you really got to have your thinking cap on for today, because you guys know the steps. If I were to give you an equation like f of x equals x squared plus 4x minus 1 and say, find the critical values, you jump right to it. Find me where it's increasing, decreasing, you guys would jump right to it. Find me where it has an inflection point. You guys could all do it. You guys just did it on the quiz, right? But that's the thing. Today, the piece of information they're giving you is not that. In fact, they're not even giving you the original. They're giving you the graph of the derivative and saying answer the same questions. So you really got to put your thinking cap on. So you really have to kind of, it's tough. It's tough. Okay? But just think it through. Keep what you know is true. If they ask you something about increasing, decreasing, we need the first derivative, right? If they ask you something about relative maximum or relative minimum, we need the first derivative. If they ask you something about absolute maximum minimum, we need the first derivative. Okay, if they ask you something about concave up or concave down, we need the second derivative. If they're asking you something about points of inflection, we also need the second derivative. Keep those in mind, okay? Because those are always true. Just because today's doesn't look like what we did last week, it's always going to be true. Okay, so let's go. Let's actually go down and look at the first question. Okay. All right. Let me erase this here. Okay, here we go. Here's the picture. So find the x-coordinate of each critical point. Critical point. So tell me what a critical point is, not the steps. Find the derivative, set it equal to 0, and solve. Don't tell me the steps, because that doesn't help me because I don't have a function. Tell me, how do we know something is a critical value? Tell me how we know something is a critical value. Yeah. When the slope of the original, when the slope of the tangent line of the original is 0. Okay. I don't have the original in front of me, right? I don't have the original. The picture there is not the original. It's the derivatives. Well, what do we know about critical values? What are their derivatives always going to be? Mhm. What are the critical values? What are the derivatives of critical values always going to be? What do we always set it equal to? 0. Okay. So where on here would you have a derivative of 0? Where on here would we have derivatives of 0? So -4 for sure, right? -4 for sure. We talked about that one, right? -4 has a slope of 0. How do we know -4 has a slope of 0? Because it's on the x-axis, right? Where else on the x-axis? 0 and 6. Okay. So we would say critical values of y equals f of x at x equals -4 and x equals 0. Okay. All right. Letter B. Find the x-coordinate of relative extrema. Okay. Relative extrema. Label each as a minimum or maximum and justify each response. We've justified before. We haven't done it in a while, but we've justified before. I didn't ask you to justify on the quiz, but they will ask you to justify. Okay? Well, before we get to the justification, let's get to where are the relative extrema. Okay, so think of last week. How did we find relative extrema? You guys did it on your quiz. You guys found relative extrema several times. How did we do it? What did we do? What did we do? How did we find relative extrema? Don't worry about the picture right now. Just tell me the steps on how we found relative extrema. What did we do? Excuse me, yeah. Yes, exactly, right? We found out first where f prime was positive, increasing, or f prime was negative, decreasing. That's going to be word for word, that's going to be our justification. Okay, so let's go find that on the graph. Where is f prime, increasing or decreasing? Think about it before you answer. Where is f prime increasing or decreasing? Where is it decreasing? There you go. I was waiting for someone to say, like, someone always says this. Someone always tells me this. First thing they say is, "Oh, it's decreasing right here." Or sorry, it's decreasing, right? It's decreasing there. That green part, is f prime decreasing, increasing, or neither? Why is it increasing? Here you go, right? This is the graph of the derivatives. These are all of the derivatives. So if something is increasing, what type of derivative is it going to have? If something's increasing, what type of derivative is it always going to have? Positive derivative, right? So where are all the positives? Right there. This is negative derivatives. Green is positive derivatives. Purple is negative derivatives. Okay, so let's go back. So we know we have critical values at -4, 0, and 6. Let's start with -4. What tells us if something is a maximum or minimum? What tells us if something's a maximum or minimum? What did we use to determine if something was a maximum or if something was a minimum? You did it on your quiz. Hmm? Okay, I can't plug in values because I don't have an equation. So don't tell me the steps. Tell me what was the reasons why something was a maximum. Why was something a maximum and not a minimum?
Positive was changing into a negative, then it was a maximum, negative was changing into positive.
Something changed from positive to negative and negative to positive. Yeah, what changed from positive to negative or negative to positive? Something changed. The f prime. F prime changed from positive to negative. If f prime changed from positive to negative, write this down. Right? It's all over your notes. All over your notes. If f prime changes from positive to negative, what does that denote? Relative maximum, right? If f prime changes from negative to positive, what does that denote? A maximum, okay? So relative maximum, minimum, relative minimum, okay? All right, so let's go. Let's take a look at -4. Is that a maximum or minimum at -4? Because why? Because the values, the y values are positive here, and then at this point, it changes to negative. Remember, all of these points are f prime. These are all the derivatives. So the derivatives are all positive here above the x-axis. At that first red dot, they change. They change, right? So we would say, So let's just label it for right now. We'll say relative max. I bet all of you are going to write that down, but do you know why? Can you come back to it tomorrow and know why that was a relative maximum? We'll find out. Maybe we'll have a quiz again on Friday. Okay? Every single one of you should have this written down like 12 times right here on the board. And I didn't see anyone write this down because a picture will help you today. This will help you forever. Okay? Right? Here's a future reference. If I write it down, you should write it down at least once, if not 38 times. Because I've taught this class for a long time. I took calculus, a bunch of calculus classes. I already know this stuff. You guys are doing it for the first time, right? So should I write it down? At least once, if not 38 times, okay? Because, and when I ask something like, why is it a relative maximum? Don't stand and look at me in the forehead, right? It's not written on my forehead. Where is all this stuff written? In your notes, right? Right? I get questions, can we use our notes? If you don't even use them in class, why am I going to let you use them on the test, right? Show me you use your notes, right? I didn't see one person flipping. Oh yeah, that sounds familiar, right? Right? That's what you got to show me if you want to use your notes more often. Okay, and I don't see it. So, all right, so here we go. Relative maximum. All right, let's go to the next one. 0. Is 0 a relative maximum or relative minimum? Okay, I agree. Relative minimum. Okay. How about 6? What is 6 going to be? You guys said 6. Is 6 a relative maximum or relative minimum? Nothing changes, right? So is it a critical value? No, look I didn't write it down, right? It's not a critical value because nothing changes. The definition of a relative maximum is f prime changes from positive to negative. The definition of a minimum is f prime changes from negative to positive. That's the definition, right? It doesn't do either, so it's neither, right? Okay, so we know what a relative maximum is, and we know what a relative minimum is. Let's see. Okay, so let's write this down. Relative max at x equals -4. Relative min at x equals 0. This is, I'm telling you right now, mark it down, write it down, whatever you need to do. You will have a question like this on your next FRQ. Your next FRQ will have a question like this where I ask you these questions. AP loves these questions. And guess what? They make them calculator questions too. You know why they make these calculator questions? Because there's no way you can use your calculator. How can you use your calculator to solve any of these? You don't, right? It's knowledge you have to have, right? That's what they always put. You can look up the last 10 to 15 years and they have problems based like this because they love these problems because these are the problems that really show your problem solving skills, critical thinking skills, because you have to take what you know and apply it to something new. Okay? So this will be one of your, if not your only FRQ. This question like this. I'm going to pick a different function and you'll have to answer questions like that on it. Okay? So anyway, this question will be worth 3 points. But I haven't got all 3 points because I need justification, right? Where is justification? Justification is the definition. It's right here. It's a maximum because f prime changes from, don't need to look up here because it's written in your notes, right? This is written in your notes. Positive to negative, right? And then a minimum because f prime changes from negative to positive. Those are the definitions of a relative maximum, relative minimum. That's why we said they were maximums and minimums last week when we did those guys, right? The pluses and the minuses on the number line, right? We had functions back then, f of x, so we could do that. But now we can't rely on that. So we have to use definitions. This 0 on this example here, 0 was a relative maximum because the derivative was positive before, negative after. That's the definition of a maximum. Definition of a minimum means the derivative was negative before, positive after. Okay? All right, so those same definitions we use, but now we have to actually use them. All right. Okay, so next one. Where is it increasing? Where is it decreasing? Where is f increasing? Where is f decreasing? So what do I need to know? What do I need if I want to find out if f is increasing or decreasing? What do I need?
It's increasing whenever the graph is above the x-axis.
That's not the definition. What is the definition of increasing, decreasing? When what? There you go. When the derivative of f or f prime is positive, right? That's exactly what you said. But the definition, I'm talking about the definition. So when the derivatives are positive, f prime, it's increasing. When the derivatives are negative, it's decreasing, right? That's increasing, decreasing. I'll write that down up here too. F, you already have it in your notes, but let's see. When f prime is positive, f is increasing. When f prime is negative, f is decreasing. And when f prime is 0, it's not increasing or decreasing. It's got a horizontal, it's got slope of 0. Okay? So now let's go look at the graph. Where is f increasing? Again, I'll have students say this. Oh, it's decreasing here. It's decreasing here. No, because this is not f. If it was f, I'd say you're right. But this is f prime. This is the graph of all of the derivatives, right? Above the x-axis, positive derivative. Below the x-axis, negative derivative, right? So from black dot to red dot, it's positive. F prime is positive. So if f prime is positive, it's increasing. Okay? So let's make a little list here. Okay. Increasing. Okay. Increasing from -6 to -4. You don't need to look up here. Look at your picture. You have the same picture I do. Okay. Where is it also increasing? From where to where? From 0 to 6, right? I highlight mine. It helps me. It's visual. It helps me. You know? That's why I highlight mine. You know, so sometimes highlighters help, right? Markers. Okay, that's where it's increasing. Okay, so now decreasing. All right, let's go back up. Decreasing is underneath the x-axis, so that's -4 to 0. Okay, so we have those answers. Now we have to give justification. Justify your answer. Use the definition. Increasing when f prime is positive. So we're going to say it was increasing because f prime is positive. And it was decreasing because f prime is negative. Okay, that's the reason why. All right. Now points of inflection. Points of inflection. What do we need for points of inflection? Second derivative, right? Second derivative. What specifically about the second derivative do I need for points of inflection? What specifically do I need about the second derivative for points of inflection? The critical value. So what does that mean? Why is it a critical value? If it's, what makes it a critical value? You're right, I do need critical values for the second derivative. I just told you. What about the second derivative makes it a critical value? When the second derivative equals 0, right? The second derivative equals 0. When the second derivative equals 0, it's a point of inflection. Okay, so when the second derivative point of inflection. Okay. Okay. So let's go back to our graph. How do I find inflection points using this graph here? How do I find inflection points using that graph there? What am I looking for? Think about it for a second. What am I looking for? Right, this is the graph, right? This is the graph of the derivatives. Hmm? Concat, yes, but you're referring to the, so you're right, but it's not going to help me here, because if this was a graph of f, then I would look for concavity, changes on concavity. But here's the thing, it's not f, it's f prime. So what's the relationship between what I'm looking at and what I need? What's the difference between what I'm looking at and what I need? What's the difference? Hmm? This is not the second, this is the first derivative. And what is this? So how do I find it? There you go. I need to find the slope of the tangent line for all of these points here. That's what I need to do. The slope of the tangent line of all of these points here, right? That's what I need. If I were to make a graph of the second derivative, I would need to find the slope of the tangent line for every single one of these points here. This point, all of the points, right? That's what I need. Okay. Well, I don't want to create a new one. I don't want to create a graph. I could, but not right now. What I want to do is figure out what am I looking for? Where are the points of inflection going to be here? When the slope is 0. Good. So look at this graph. When is the slope equal to 0? When is the slope equal to 0 on this graph here? Not -4. -4 right here, the slope is 1, 2, 3, 4, -2. The slope of this guy is -2. When is the slope of this guy 0? -2 is definitely one spot. I would say -2 is definitely one spot. If I were to draw a tangent line at this red dot, it would be horizontal, right? Where else?
What about a non-linear and say 4?
What's the slope of the tangent line at 4? If I wanted to find derivative at 4, what would that be? Not 0. What's the slope at 4? If you wanted to find the slope at this dot right here, what would that be? Not one person looking in their notes. This is in your notes. It's too late now. Next time you ask, Mr. Flores, can we use notes on the quiz? Can we use notes? No, no. Right? Hold on. Thanks. Okay. What is the slope? I'll remove the dot so you can give you a little better picture. What is the dot or the slope of the tangent line of this dot right there?
Should I say 0?
You're the third person to say 0, and every time I've said no. So it's still no. If I find it first, ooh, that test is going to be really tough next time. No? I know exactly where to look too. Doesn't that look like that? Doesn't that red dot? What do we call that? What did we call that last chapter? Corner. Right? So let's go back. We said the slope at that red dot, there was no slope because it didn't fulfill this. What does this say here? Mm-hmm.
Limit as x approaches c from the left equals
No, there's no limit.
Oh, wait, no.
The derivative of what? The derivative, keep going. The derivative. I know this means derivative, but what does this mean? What does this whole thing mean?
Derivative of the c from the negative on the left side will be equal to the derivative of the c.
Exactly. The derivative going in, the derivative of all of these points here is a part of this line. So all of these would have tangent lines that run like that. So all of these points that make up this segment here have all the same derivative. At this point, it changes to this now. So the derivative going into that point is different than the derivative going out of that point. By definition, there is no derivative at 4. There is no derivative at 4. 4 does not have a derivative.
But doesn't the problem at the top since it's differentiable?
That's a good point. Yeah. At the very beginning, it says it's differentiable. What does it say is differentiable? It says f is differentiable. We aren't talking about f, right? What are we talking about? F prime. So f prime is not differentiable at 4, right? That doesn't contradict anything they've told us, because they said the original is defined everywhere and differentiable everywhere. That's true, right? Otherwise there would be asymptotes, or there'd be a hole here or something like that. But there isn't. But what's not differentiable is f prime, right? F prime. Okay? So at f prime of 4, sorry, f double prime of 4 doesn't exist. Does not exist. Okay? So let's go down here. Point of inflection. Is that considered a point of inflection, though? If I get one of those guys, is it considered a point of inflection? We know when it equals 0, that's a point of inflection. We know that. But if I get an undefined slope or an undefined derivative, does that give me a point of inflection? And I'll give you an answer. The answer is not on my forehead. It's not on your desk either. It's not on these notes either. Yes. If so, when do I have points of inflection? When do I have points of inflection? That's my question. I know half the answer. I know when f double prime equals 0. All right. Again, if I find it first, ooh. Well, that's what I'm asking you guys. What does it mean by an inflection point? How do I know something's an inflection point? Because I have to justify it, right? So if I say this is an inflection point, I have to know why, right? I have to know why it's an inflection point. We define an inflection point as the point of f where the graph changes concavity. That's the only spot where you had inflection points. If you couldn't find it, your notes need to be better organized, right? They're not just papers you throw in somewhere. You need to be better organized with where you can find them, okay? We define inflection point as the point at where f changes concavity. We don't have f. We don't have f. We have f prime. So change the wording around. So we define inflection points as the point on f prime where the graph changes what? That's for f. We don't have f. This graph right here, this graph you guys are looking at, that's not f. That's f prime. So how can we change this wording here so that instead of f, we say f prime. So we define an inflection point as the point on f prime where a graph changes what? F prime. So I want to say the same thing. I want to say the same exact thing, except I don't want to use f because I don't have f. I want to use f prime. You're close. You're close. How did we know we have an inflection point at -2? What did we say? We had an inflection point at -2 because what? Okay. So what's true about slope of being 0? The answer's not on the clock either. Okay, so instead of concavity, we can't use concavity because concavity only works when we have f. Okay, so you guys are right there. Instead of increasing, decreasing, don't use increasing, decreasing. Use what we've used up there. What is increasing, decreasing a symptom of? It's increasing because? Okay, what is it? The slope of what? No, not the slope of f. No, okay, the slope of f prime, okay. What is that called? There you go. Because f prime changes at this red dot right here. At this red dot, the slope changes from what to what? Don't say it like this. Say it louder so I can hear it. From negative, the slope was negative here, right? The slope of the tangent line was here. There you go. Okay? It's a point of inflection because the slope was negative before and it's positive now. So let's write that down. F double prime changes from one sign to the other. Changes signs. Yeah, let's just say changes signs. We don't care about next question. We will care which one it changes from. But this one, let's just say changes signs. Okay, so go tell me where on that graph f double prime changes signs. We already said -2. Where else does it change signs? At 4 as well, right? You had a positive slope before, had a negative slope after. I think that changes direction. So we would say point of inflection at x equals -2 and x equals +4 because f double prime changes signs. Okay? Yes.
I'm really confused. So, like, at first we said 4 wasn't an inflection point because it's not equal to 0. But if you take this other instance, like it's changing sign.
Because that's why I went back to the definition. What was the definition? I was saying, well, what does inflection point mean? Do we care? Does it just have to be 0 or can it be undefined? Let's go back to the definition. And the definition just says where it changes, right? They said concavity because they were referring to f. Well, if we're referring to f prime, we're not going to use concavity. We're going to use change of slope. That's why. Okay, that's why. So what I want you to do, because to finish the rest, is this list here we made earlier. Give me reasons why we know it's increasing, decreasing. Give me reasons why. Give me reason. How do we know all of these things are true? How do we know all of these things are true? The better you can do that, the easier this will be. Okay? Because a lot of you know, oh, it's an inflection point because we set it equal to 0 and da, 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 da. Yeah, but why? What's the definition? Why? And we did all that in our notes. So it's not like you guys have to go very far. It's all in your notes, right? But you have to have a better way of finding those things quickly because, okay, that's what I want you to do tomorrow because I'm going to give you your own problem tomorrow. We have a couple things left to do on here, and then I'm going to give you your own problem, and I want you to be able to find that. So for right now, what I want you to do, your homework assignment, is to give me definitions. How do I know each of these is true? What is the definition? Give me definitions on how I know it's increasing, decreasing. How do I know f prime is increasing, decreasing? How do I know it's a relative maximum or minimum? How do I know it's absolute? How do I know it's concave up? How do I know concave down? Or how do I know it's points of inflection? Okay? Because the better you have that, the easier this will be. If you have definitions, you know what to look for. If you don't, it's going to be tough. Okay? It's going to be tough. All right?